So if we look at our exponents, if we look at just the exponents of our x's. So if I'm just looking at the exponent for x's, look at this. We have x to the third plus 3x squared y plus 3x y squared plus y cubed. Well, the exponents for just the x are going to go 3, 2, 1, and this is actually x to the 0th power here. So our first term, our x's, are going to count down 3, 2, 1, and then go to 0. And that is based upon our original power that was given. So your first term with your exponents are always going to count down from whatever number this is until it gets to 0. Your second term is a y. And if we do this exact same thing, we're going to recognize that it actually counts up versus down. So if I have x cubed plus 3x squared y plus 3x y squared plus y cubed, if we look at just the y's, we're going to start with a power of 0. Then we're going to go 1. Then we're going to go 2. And then we're going to go 3. So in fact, the powers of an exponential, not an exponential, but a binomial expansion are relatively easy. As long as you know what power you're raising your binomial to, your first term counts down from that, and your second term starts from 0 and counts up to that. So you actually should know how many terms you have in your answer. Now let's talk about coefficients. For coefficients, we have for x plus y equals 0, we just have a 1 for a coefficient. Because if I go back here, we just have 1. For x plus y to the first, we have a 1, 1. Then we keep going down. Our coefficients turn to 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Well, that's something called Pascal's triangle, where you can actually come up with every single level you want to, and this is how it works. So Pascal's triangle starts with a 1 on top. And then it goes 1, 1. So you have to know how it starts off. Then the next row is dependent on the row above it. We are going to do 1 plus 1 is going to give you 2. So our next row will start with a 1, end with a 1, and have a 2. The next row is going to start with a 1 and end with a 1, but what we're going to do is we're going to add the two things that are above it. So we'll have 1 plus 2 would equal 3. 2 plus 1 would also equal 3, and you have 1s on the outside. Continuing down, we'd have 1 plus 3 would equal 4. Then we'd have 3 plus 3, which would equal 6. 3 plus 1, which would equal 4. And we'd have a 1. Well, if I need to go one step further, it would be 1, 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. And we end with a 1. Those are all the coefficients to our binomial expansion. You just kind of have to keep straight which level goes with which expansion. Yeah?
Does this just work for x plus y, or could it be like 2x plus y?
It could be 2x plus y. You just got to worry about multiplying it. So if you have 2x plus y, let's say we had a 5 out front, and we just have 2 in there, it would just be 5 times 2, which will make it 10. Yes, so this is what we're going to use to write it. It might not be your final. It might not end with a 10 there. It might turn into a 30 because you have to multiply that number. But like I said, the only hard part about doing it with this method is just keeping track of the fact that this was x plus y to the 0th power. So the 0th power leads you to your first row. The first power is actually going to be your second row. When it's squared, it'd actually be your third row, and so on and so forth. So you really have to go one extra row. So if I'm on x plus y to the third, I'm going to go to the fourth row. So let's put both of these things together to actually expand a binomial without having to do the entire thing by hand. So we're going to put together our exponents, we're going to put together our coefficients, and we're going to be able to write the whole thing without doing the complete multiplication. So our first one is x plus 2 to the fourth. You could do it by hand. It's still several steps. Let's take care of the exponents first. So what I'm going to do is I'm going to put a little equal sign. I'm going to put a space for my coefficient. And I'm going to say, okay, for our exponents, we're going to take x as my first one. So it's going to be x to the fourth, to the third, squared, to the first, to the 0th power. So we're going to have x to the fourth. Let's leave a space plus a blank. Then we'll have x cubed, a space for our 2. Then we'll have plus blank x squared. Leave a space plus blank x to the first, blank plus x, and I'm going to put x to the 0th. So our x's go 4, 3, 2, 1, 0. Now 2 is our second term. Our second term starts to the 0th and then counts up. So we're going to have x times 2 to the 0th. Then we're going to have x squared times 2 to the first. Then we're going to have times 2 squared. Oh, I missed one. That's why I was zoomed in too far. This one should have been our 2 to our 0th. This should have been 2 to our first. Times 2 squared. Times 2 to the third. And finally, we're going to have times 2 to the fourth. All right, now our coefficient just is based upon your Precalc triangle. Now, one way you can look at it is it's 4, so we're going to be on line 5, or you can just see the line that matches up. I have 1, 2, 3, 4, 5 spaces. So we can just find the one that has 1, 2, 3, 4, 5. Well, that's the 1, 4, 6, 4, 1. So that's exactly what we're going to plug in there. 1, 4, 6, 4, 1. Now we just need to simplify all this. Well, 2 to the 0th is 1. 1 times 1 is 1, so we're going to have x to the 4th. Plus 2 times 4 is going to be 8. X cubed. Plus, well, 2 squared is 4 times 6 is 24, so we'll have 24 x squared. Plus 2 cubed is 2 times 2 times 2, which is going to be 8. 8 times 4 is 1632 to the x. And finally, we're going to have 2 to the 4th, which is 2 times 2, which is 4 times 2 is 8 times 2 is 16. So this is going to be plus 16. X to the 0th is 1, so we'll just have 16. So that's what we were talking about, Safa, that you won't end with 1, 4, 6, 4, 1, but you use it to come up with your final thing here. Yes?
So the y's just become coefficient?
The y's become a coefficient?
Yeah,
What y's? I'm sorry.
the y's. Because you said... Because, like, in the thing...
Oh, in the example up here, we had y's.
But then the 2's the y,
Yep.
and then the 2 becomes the...
It takes the place of the y, yes.
Okay.
It just becomes what you are.
But that becomes the coefficient.
Yes, because it's a number we can actually plug in. I see what you mean, yes.
Okay.
It affects our coefficient. Yep. If it was just y, it wouldn't, because we can't multiply it. But as soon as it's a number, then we can apply it to the front. All right, and that's our final answer. We did all that without having to do all that distributing over and over and over. Mark, why are you playing the computer?
It won't work.
Oh, okay, let's just close it for now.
Okay.
All right, the next one we're going to do is x minus 3 to the 5th. This one is slightly more complicated in the fact that we have to think about it differently. We have to think about this as being x plus negative 3
Plus 0.
to the 5th, where your y value is now negative 3. So you're actually going to do negative 3 to the 0th, negative 3 to the first, negative 3 to whatever. So we always have to use negative 3 in parentheses. All right, let's tackle the exponents first, and then we'll do the coefficients second. So this is going to equal some coefficient, and x is our leading term, so it's going to start x to the 5th. Our second term is going to be negative 3 to the 0th. So I'm going to take care of both of them at the same time. Then we'll have plus some coefficient. Well, my x is going to count down while my negative 3 counts up. So we're going to have x to the 4th, negative 3 to the 1st. If I stop right here and we look at something, your exponents will always add to your original exponent. 5 plus 0 equals 5. 4 plus 1 equals 5. It's a nice way to be able to check that all of your terms are correct. So our next one, we're going to have something, x counts down, x to the 3rd, negative 3 squared. 3 plus 2 equals that 5 again. Then we'll have plus coefficient. We'll have x squared times negative 3 to the 3rd. 2 plus 3 is 5, plus a blank. Then we'll have x to the 1st, negative 3 to the 4th. 1 plus 4 is 5. And that's going to be plus. Ooh, I really ran out of room. Stupid writing big. All right, we're going to have a blank, and we're just going to have negative 3. I'm going to call it the expo of negative 3 to the 5th. All right, because we're to the 5th power, we'd be on our 6th row of our Pascal triangle. Or we can just count how many terms we have. We can count how many terms we have. We have 1, 2, 3, 4, 5, 6. Go to your Pascal triangle. 1, 2, 3, 4, 5, 6. It's just 1, 5, 10, 10, 5, 1. 5, 10, 10, 5, 1. All right, then we just have to do this math. All right, negative 3 to the 0th is 1, so we're going to start out with just x to the 5th. Well, now we're going to have negative 3 to the 1st, which is negative 3, times a 5 is going to be negative 15x to the 4th. For our next one, we have negative 3 squared, which is a positive 9. 9 times 10 is going to be 90. X cubed. Negative 3 cubed is going to be a negative 27. Negative 27 times 10 is negative 270. X squared. And then we'll have negative 3 to the 4th, which is going to be, what is that, 81. And we times 5, so that'd be 400, no.
405.
Yeah, what did I mess up? Why did I think that's not right? No, that's right. Plus 405x to the 1st. And then we're just going to have negative 3 to the 5th. And what is that one?
243.
What was that? 243. So is that negative or positive?
Negative.
Negative. It is negative. Any negative power to an odd is always going to be negative. Any negative to an even is going to be positive. And that is our correct answer. And that, I guarantee you, is infinitely easier than going, okay, x minus 3 times x minus 3, factoring it out, and then doing x times x minus 3, then times x minus 3. This is infinitely easier. In fact, you won't be able to do the test in time unless you know this. Let's make this easier. Pascal's triangle is awesome. But if I want to go any further than the 5th, I'd have to keep writing rows and rows and rows. And eventually that gets very, very tedious. So instead, there is a way to write Pascal's triangle using combinations. Remember, this is a way to write combinations. So this is C00. This is C10, this is C11, this is C20, this is C21, this is C22. All of these are combinations. So these are all formulas we can do. Well, if we look at this, when I'm dealing with x plus y to the 0th power, there's just one term and it's 0, choose 0. Well, when I'm doing x plus y to the first, my first one is 1, choose 1. My second one is 1, choose 1. If I am doing x plus y squared, that's going to be 2, choose 0, 2, choose 1, 2, choose 2. That will tackle all of my coefficients without having to draw that whole thing over and over and over and over again. So what we're doing on every one of these rows is every one of those are going to be your exponent. So if I have x plus y to the 4th, I know I'm going to use 4, choose 0, 4, choose 1, 4, choose 2, 4, choose 3, 4, choose 4 to work my way down. If I was to the 10th power, I know every single coefficient to the 10th power. Your first coefficient is 10, choose 0. Then it's 10, choose 1, 10, choose 2, 10, choose 3, 10, choose 4, and so on. And it turned into Chen at some point, didn't it? So, in effect, if you have something that's like, I don't know, 11, choose 0, and I'm asking what term that is. Well, there's two things you know. You know your exponent, and 0 is going to be term 1. That is your first term. 1 is going to be your second term, 2 is going to be your third term, so on and so forth until you get to your last term. So you actually know your exponent and your term if I give you that information. All right, that leads us to something called the binomial theorem. Your binomial theorem has everything we just did included in it. It has your first term counts down, your second term counts up. Because when you plug in r equals 0, you're just going to have your r value up here, and b is going to be 0. And then right in front of it is going to be your coefficient. I think it makes a little more sense when we actually do some problems with it. So let's go ahead and just use it. We're not going to use it in the Riemann sum formula. We're just going to use it to write the first 3 terms of this expansion. We're going to write the first 3 terms of this expansion. So the first thing you're going to look at is your exponent is 10. Your exponent is 10, so you're going to do 10 choose some number for every single term. So for our first coefficient, we are going to have 10 choose 0. And then our x value is our first variable, our first term in the binomial. So we're going to have 10 choose 0 times x to the max. That would be to the 10th, x to the 10th. Then we're going to have negative 2y to the 0th power. Our next term is going to have a coefficient of 10 choose 1. Then we're going to count down with our x, so we'll have x to the 9th. Then we'll have negative 2y to the 1st. Our next term is going to be 10 choose 2, and that's going to be x to the 8th, and we'll have negative 2y squared. It just wants the first 3 terms, so we don't have to do anything else after that. It just continues and continues and continues on. If I have 10 items, how many ways are there to choose 0 of them? What was that?
1.
There's only one way. You don't choose any of them. Correct. So 10 choose 0. You don't have to do the math. You can. You can do your 10 factorial over all that stuff. But 10 choose 0 actually just equals 1. And then we'll have x to the 10th. Negative 2y to the 0 is just 1. For the next one, we could write down the whole step. So 10 choose 1 is 10 factorial over 10 Let's just shortcut it. So 10 minus 1 would be 9 factorial times 1. And that's going to be times x to the 9th. Negative 2y to the first is just negative 2y. Then we'll have plus 10 choose 2, which would be 10 factorial, over 10 minus 2 is 8 factorial, times the 2 factorial, times x to the 8th. Negative 2y squared turns out to being a positive 4y squared. All right, let's keep going. So our first one is 1 times x to the 10th, so that's just x to the 10th. 10 factorial divided by 9 factorial is just 10. And then 10 times the negative 2 would be negative 20 x to the 9th times y. Plus, well, 10 factorial divided by 8 factorial times 2 factorial is actually 10 times 9 divided by 2, which is going to equal 45. So I have 45x to the 8th. And then we have that 4y squared plus dot, dot, dot. So our end result is x to the 10th minus 20x to the 9th y plus 4 times 45, 90, 180. X to the 8th y squared dot, dot, dot. This problem is not solvable without knowing this. Well, it's solvable. It's just going to take you hours and hours. Yeah, Mary.
I'm like still super confused where you got your y exponents.
Where I got the y exponents? These?
Yeah.
So our x's always start at 10 and count down.
Yeah.
Our second term, which is that negative 2y, is going to start at 0 and count up.
Oh, is that a 0? I thought that was a 6.
Oh, sorry, yeah, that's a 0. So it goes 0, 1, 2, 3, 4, 5, 6, all the way up to 10. Yeah, sorry, that's a 0. Yeah.
So what does the like sigma thing have to do?
That means keep adding every one of them.
Oh, so you don't need to use that?
Well, we did. We actually did without really recognizing it. We plugged a 0 in for both of our r's. So I had my first term, which is x. I did x to the n minus r, which was just my n. So that's why we have the 10. And when I plug a 0 in for my second term, I have whatever my second term is to the 0th.
Okay.
And then my leading thing is n, whatever this value is, divided by what r you're on. Well, we're on r equals 0. And then for the next one, our r becomes 1, and then 2. So we did use it, but I think it's a little easier not having to plug numbers in and just know what's happening.
Yeah.
Know that your first term counts down, your second term counts up, and then we just have 10 over 0, 10 over 1, 10 over 2, and continue on from there. So we did use it. I just think it's a little easier to use intuition versus plugging numbers in and going from there. But that is our final answer. Those are your first 3 terms. All right, the next one is slightly different, but very, very similar. It says, what is the coefficient of a to the 7th b squared in the expansion of a plus b to the 9th? So if you remember, our coefficient is just a choose function. It's a number, choose another number. So at the top of it, I did write it kind of out. So we're looking for what goes in here in front of a to the 7th b squared. Well, the really, really easy part is just the 9. The 9 comes from right there. That is always going to be on the top of your choose function. If I didn't give you that, 7 plus 2 also gives you your 9. These 2 exponents always add to your beginning exponent. So you could have just go, a to the 7th b squared, that's going to be 7 plus 2 is 9. 9 on top. Got that one covered. Now we have to figure out what we're doing here. Here's a really nice shortcut. what goes here is always going to be your second exponent. It is always going to be your second exponent. It's always going to be this here. So we get the 9 from adding these together, and we get the bottom one from just our second exponent. And now our problem is just 9 choose 2. Well, 9 choose 2 is just going to be 9 factorial divided by 9 minus 2, which is 7 factorial, times 2 factorial. Well, that's going to equal 9 times 8. Let's do the whole steps. Times 7 factorial over 7 factorial times 2 times 1, which is just 2. Our 7s cancel out. You could go a little further and say, okay, that 2 will cancel out with that 8, and that 8 will become a 4. So it really is just 9 times 4, which is going to equal 36. So this is definitely one you don't need a calculator for. So this could fall into the you cannot use your calculator at all. You have to determine what's the coefficient of a to the 7 b squared. Just so you know, the spacing on the homework's a little weird on the backside. You don't need all that room on the last 3. You might need some more room for the last one, but if you don't use up the entire space and you have an answer, just stick with it. All right, just how the flow kind of worked with it. All right.